Hello. Okay, good afternoon. Welcome to come to the tutorial 1. I have updated the GitHub link, so you can find some useful information for today, the tutorial 1 midterm exam. I attached some useful links that we may use today. Sorry, this one doesn't work. I will figure this out later. And you can see we have some material in the link at the bottom of it. It's from the previous year. You can check the answer for the tutorial, and then there are also some useful notes for the preparation. Let's just have a quick look of it. This is the sample question for the final exam, but you don't need it right now. And we have some merge slides in here. You can see, you can download this one by yourself. But this one, I think it's not new one. I will try to update to the newest one. Basically, just merge everything into one PDF file. So you don't need to switch different file to find the stuff. For example, you want to figure out what is the DNS, right? So you just search in here without crossing different slides. So this one is pretty useful when you're doing the midterm exam because we don't have much time to search around different files. So before you take the exam, it's better to have a merged version of the slides. For example, you don't remember what is tit for tat. So you just search in here, tit for tat. And I also made some notes on the slides. You can see I highlight this kind of content because I think they are useful and they are always be tested. So if you have time, you can go through these slides by yourself. You can check. I highlight some stuff inside these slides. So you can check them one by one. And yeah, that's it. This is the first thing I want to mention here, the merge slides. You can find it inside this link. So come to the, where's the page? This is the page, right? I have sent the link into our chat. Then you can go to the useful information here and come to the merge PDF. Then you can see my files. Let me open this one. This is the merged files. So go through all the highlight content here. For example, the delay in the first slides, you can check what is delay. I think I highlight the title of this one because I think this is important in the midterm exam. So you can go through all the highlighted stuff. But if we have time, we can go through it today. And yeah, that's it. Okay, so what's the next thing? It's about assignment demonstration. We will have some help session for assignment on week 5, 7, and 9, 7, 8, 9, every Thursday and Friday. But of course, we have, I think, maybe 4 session or 5 section every week. I will do the Python one. So if you plan to do your assignment on Python, you can come to the help session, and here are the schedules. On week 5, we will have an overview for the assignment. So I will introduce how to do it and what should we do for the assignment. And I will show you some demo code for the server and client, just like we did in weeks 2 and 3. And next one is the assignment structure design in week 7. So I will discuss the structure of the assignment with you, how to design an efficient application for the assignment. And week 8 is about the key function demonstration. So for example, if we need to send the file like via P2P, I will show this kind of function of how does it work and how to write this kind of code. And we will have some discussion. And in week 9, we will have the test case. So I will share some test case, maybe in this link. I will add more thing in the GitHub link about the test case. So you can run the test case for your assignment and have a check if you miss something. And if you can pass the test case, I can make sure you have at least 80% of the marks. And yeah, that's it. Will the assignment demo session be recorded? Yes, we will. I will update a recording link below this part after week 5. So just gradually check this website. So I will put every recording and useful stuff into the link. So it could be useful. Okay, so let's have a look of the midterm exam content. But if someone wants to have a check of the tutorial in here, tutorial 1, but I would say this kind of stuff is quite outdated. So you can try to do it by yourself, but sometimes you think this kind of question is quite confusing, and sometimes that you're not familiar with that. But I would say the midterm exam will be a little bit different from this one. So just don't consider this one is the midterm exam question. I think this one is a bit like harder than the midterm exam. And some part of it, we didn't cover that. So don't worry too much about the tutorial 1. I would like to leave this to you because we already have the answer in here, I think, in the links. In the tutorial 1, we already have the answer in here. So I will leave this kind of thing to yourself so you can do it later. But we will try to figure out how to do the midterm exam preparation and how to do the other thing before we attend the midterm exam. Is that okay? Because I think the answer is pretty clear for this one. So, but if you do have any question, feel free to ask. So we can go through the midterm exam details at first together. Okay, let me open my slides. Yep. So for today, I would like to have a check of this kind of slides with you. We have four part of content: network, introduction, and application layer, transport layer, including UDP and TCP. So in the midterm exam, the part 2 and 4 is very important. The application layer, including the HTTP and what is that? DNS and P2P. And for the TCP, we will have some simple calculation on that part. Before we do that, we can have a quick look of the statistics from previous year. So this is the statistics from last year. And you can see we have 450 students, and the maximum mark, which means the highest score, is 19.5. No one can get full marks. And the median is 10.7. So do not have much expectation for the midterm exam, because most of the students will get around 11, right? 10.43. And here are the distributions. And yeah, just the top students. You can see the first one is 19.5 and the third one is 18.6. It's not close. So I would say the midterm exam, it's pretty hard to get like above 15. This is because you don't have much time to do every questions. So I would like you to do more preparation if you want to get high score. Do you have any questions? And the time of the midterm exam will be in week 7 on the Monday. So just right after the week 6. In the week 6 will be a midterm break, and we will just have the exam on Monday in week 7, and 10 to 12 in the morning. So if you are not in Australia, you may need to be aware of that, like you are in different time zone. So please have a check of the time and set an alarm. And make sure you connect to the like Zoom link at 9:30 or something, because we will have some we will have a Zoom link in here, right? On the Zoom link during the exam period. So test this link before you attend the exam, because you need to like report the question or report any issue during the exam if you are like having any kind of question. Like you lose your I don't know, lose internet, you cannot report it, right? Because you don't have the internet. But before the exam, you need to like have a plan B for losing internet. So you may need to set maybe a mobile hotspot before you attend the exam, just in case you lose the internet. Yes, it will be hard in different area. Maybe you need to wake up earlier. And that's basically all the things. So the content will from week 1 to week 5, and question will be multiple choice and fill in the blank. But from last year, we do have some essay questions which will ask you like answer a few sentences, like 2 or 3 sentences to describe a thing. But seems this time we don't have that. So this time we will only have multiple choice and fill in the blanks. which is great. And yeah, I think that's it. Let me check if do we have any other thing else? Okay, so let's go through some key topics together. So the first one is the packet switching, delay, and protocol layering. This one is for the first week in the network intro. So I have uploaded the files into the GitHub link, so you can have a quick look of the link. Let me open that one. So you can find the link in here and open the merge file. Open this one, and this one, then you can see in page 34, which is 34, this one, circuit switching. So we will just have a quick look of all the content from week 1 to week 5. The circuit switching is basically like a phone, like phone line. So everyone will have a fixed bandwidth and they cannot share with each other. So no sharing. And the difference between the circuit switching and packet switching actually is in here at this part. In the packet switching, it's just like the internet we are using right now. We will divide different like the whole data set into different packets and send it separately. And we can share the bandwidth. And that's the main difference between them. So you can have a check in here, figure out what is the difference between them, and you can try to answer the question. So all the question in the slides is actually from the lecture slides. You can find the same question inside the slide, like this one. So I put it into here because every question in this slide is very important. It really help. It will be like extremely helpful for your midterm exam. So try to go through all the questions inside the lecture slides before you attend the midterm exam. Otherwise, you will have no time to like answer all the questions during the exam. For example, you have the same question in the midterm exam here. You have to come to here and check it again. And you can see there's no answer in the slides. So you maybe need to check the recording or something else. Or if we come to the calculation, we may not have the same question, but we may have this similar one. For example, they will replace the number of n in here with different number. So you need to do the calculation again. So before you attend the midterm exam, probably you need to do this kind of calculation by yourself and make some notes on here. You can write down the equation in the slides. So once you have the same question, you can just quickly come to here and check the equation and do the calculation. So save your time. Yep. And so the pros and cons of circuit switching, can answer this by yourself. It's not very hard. And for this one, do you have any idea? Which resources are allocated on demand? Yes, exactly. Answer A. So if you cannot answer this question, then you need to go back to the area and have a check of the details. So how about this one? From A to B consists of actually X and Y. So we are using circuit switch network. Yes, it's the same. So if you go to the slides, you can easily figure out the answer. In page 34, I think. In here, you can see they are always using the same road. And this one, pipe view, it's pretty easy to understand. You just try to understand we have a buffer in here, you can see in the router. And if we have too much traffic and the buffer overflowed, and we will drop packet. And that's the reason why we have the packet loss. If you still remember when we do the ping command, we have some packet loss, right? So this is the reason. We have too much traffic and our packet has been dropped by one of the router. And the delay will be a very important content for week 1 and 2. And this must be tested during the midterm exam. Will not test your understanding on here. For example, it will not ask you where is the transmission delay. This one is too simple, but we will ask you how to calculate. For example, we have a packet from A to this destination server. How can we calculate the total delay during this whole process? Then you will say, probably just add them together. But we will not give you the digit directly. In this case, you can try to do some real question here. Maybe we will do it later. We will do this one later. But let's try to do this one right now. The propagation delay depends on the size of packet. Is it true or not? So try to answer the question. So I will see if you can understand it or not. And if most of the students cannot understand it, I will explain it in details. Okay. Okay. Is it true or not? Propagation delay depends on the size of the packet. So this one is the propagation delay. Does this one depends on the size? I think this one is the question on lab 1, isn't it? Yes, the answer is false because the propagation delay only depends on the physical distance and the speed of light. And this one, what is the sequence for the delay? We have 4 kinds of delay. So which one is the first one? So the first delay, we can go back to sorry, made a mistake. Where is my slides? Sorry about that. Let me open it again. Yeah, let me open that one again. Maybe I need to open it with a different method. Yes. Okay, I will use the Chrome browser. we're in here. So in here, we will see what's the answer for this one. You can see when a packet arrives the router, the first delay should be the processing delay, right? Because the router need to read what's the content inside the packet and what is the destination of it. And it will also do some sum check to make sure the packet is valid. If it's an invalid packet, it will drop it. And the second one will be the queuing delay inside the router. So the second one is queuing. And the third one will be the transmission delay. Transmission delay will depend on the bandwidth and the packet size. And the last one will be propagation delay, will be on the internet, in the internet, and sending to the next router. So it's C. And next one, consider circuit switch network with 100 users. This one, try to answer this one. So actually this one is not the delay, but a circuit switch. How much capacity? Is it 0.2, 100, and 100? Is it 20 or 200, 100? So you can consider how much user do we have? It's 100 users, right? And what's the requirement for each one? It's 1 Mbps. So for 100 users, which will require 1 Mbps for each, which means we need to have 100 Mbps. Regardless, what is the probability? Because we are using the circuit switch network, right? On the circuit switch network, we are not sharing. So you got the wrong answer in here. You can see the answer is 100 Mbps. So let's figure out why. Let's go back to here. We can see for the circuit switching, we have a fixed data rate. So for everyone, they will use the same route, right? And they are not sharing with each other. If you go to the slide 34, they are not sharing. So which means we have to remain the, remain the bandwidth for the user, even they don't use it. So that's the reason why we choose 100 Mbps, because they are not sharing on the circuit switch network. How about this one? The same question, but we switch the network to packet switched. Yeah, exactly. So this time, because the packet switch network will share the bandwidth, which means we will only need this much. So you can see the efficiency is so like totally different. So for the internet we are using right now is this kind of network, packet switch network. So you will feel like the internet speed is a little bit slower during the night, like on the busy time. But if you are trying to download something like during the morning, probably it will be very quick. So that's the reason. Next one. Consider network connection between A and B. So a packet sent by A to B, will the packet have the queuing at R1 depends on the length of the link of R1 to R2. So I can draw something to help you to understand it. So in here, the question is, so does the length of this part will affect the queuing delay in here? So this part is the queue. Does the queuing delay for R1 affect with the length of the R1 to R2? Okay, I can see most of the you can get the answer is no, it doesn't, right? Because we can see the length only affect the propagation delay, does not affect the queuing delay. Okay, so I think you can easily handle it right now, and that's the stuff for the introduction. Let's just have a quick look of the midterm exam content. We will test the packet switching, circuit switching, delay loss, and throughput. So you need to know how to calculate the throughput. We didn't calculate in the example here, but you should be able to calculate it. And the protocol layering stuff. So for the throughput, just have a quick note. For example, the same question I have asked you in the previous labs. 100 MB file, and with the 100 M, no, this time is 10 MB BPS. How long? How to do the calculation? Okay, if it's 10 seconds, I will not ask this question, right? Try to Google it right now and tell me the answer. You have 2 minutes to do that. Yeah, so when we talk about the Mbps, you can see this one is not in capital, right? So the Mbps equal to million bits per second. So if 10 will be 10 million bits per second. Bits. Okay, so it's megabits. So you can see 1 byte equal to 8 bits. So can you do the calculation right now? The T. So this one is actually this one is what is that, processing? The processing equal to, this one is it's not the processing, sorry, it's the transmission. Okay, this one will equal to 100 MB. So times 8 divided by 10. I will add the units so you can easily understand it. MB. So that's the answer. So this one is very easy, and we will not test it in the midterm exam, but it could be a part of the delay calculation in the question. Because this one is the transmission delay. We may ask you to add all the delay together, including the propagation delay. Then you need to know how to calculate the propagation delay as well. And for the queuing and processing delay, will always be a fixed value. Okay, so this one is 8 bits per byte. So 8 bits per byte. So that's the reason. Yeah, so when you purchasing the internet plan, for example, you are in Telstra, you have a MBN contract with Telstra, which is 100 Mbps for like $90 per month. You have the contract like this, then you will get 12.2 MB megabytes per second downloading speed, right? So if you are having like 100 Mbps with your bandwidth, then you should have this much on your download speed. So this is just a part of the calculation. This part is always confusing, and most of the students cannot answer this question in the midterm exam. So I'm not saying that we will test this part, but we may test it in the midterm exam in the calculation part. So be aware of the unit when you do the calculation. I think the delay is very easy to calculate. Just divide and add them together. But when you're doing this, just be aware of that. We have some unit conversion. And for example, the 1 second equal to how much millisecond. This kind of conversion is always in our midterm exam. So it's not hard, but it's very easy to get it wrong. So make some effort on this part before you turn exam. Let's go to the next one, application layer. So we'll quickly go through it. I will not deep dive into the details. The first one should be the HTTP stuff. HTTP and what is HTTP and how it works, and the status code. We usually test the status code in the midterm exam, but I think it's too easy. I'm not sure we will test it because we are having an open book exam. But anyway, you should have a look of the status code, because if we are testing the HTTP content, the status code is almost must have in the question. So have a check of the status code. Like what is 404? What is 503? And the methods as well. So just go through the slide. It's pretty easy. But in here, I just want to explain what is the difference between HTTP 1.0 and 1.1. We can go through the contents in the slide. Non-persistent. So for the HTTP, when we try to fetch a file from the server, how much RTT do we need? Obviously, 2 RTT. So just like the map in the right-hand side. So why do we need to have 2 RTT? Any idea? So what's the first part? This part, what is that? Yes, this is the TCP connection establishment. So when we need to get a file in the second part, right, we have to establish the TCP connection. So in the HTTP 1.0, in this version, we always need to establish the TCP connection before we send a request. Like for each file, I mean, for every file, we have to establish the connection. And after we receive the file, we will immediately close the connection. Even we still need to send another thing, we'll need to initiate the TCP connection again. So the efficient is pretty bad, right? We need to establish and send it, and establish and send it. So that's the HTTP 1.0. It's non-persistent. And for the 1.1, we improve it. You can see that 1.1 in here, we only need to initiate the TCP connection at once, and then we can keep sending and keep sending. Even we can send like 3 requests in a row. You can see we have 3 requests in a row, and we will receive 3 responses in a row. So we save time. We call this part, we send 3 requests in a row, we call pipelining. Right? So you need to understand what is pipelining. And that's it. Then we can do some calculation based on this. Let's go to the calculation question here. Yep, this one. This one. Can you do the calculation? So the S0 because this one is non-persistent HTTP. I'll try to explain this part in details because to understand this one is very important. So the first one, we will just draw some steps like this. Sorry, we draw like this. Then what's the first stuff in here is we need to establish the TCP connection, right? So TCP connection, and then we will request the objects HTML file. We will request for HTML file, and which is in here. We can draw, maybe just make this one thicker, like this one. Yep, and the HTML page in here, and this part is the time that we need. This is T, because when the server sends us the file HTML page, then it need to take some time to send it, and the time equal to the package size, which is the size S divided by the bandwidth, which is the C, I think. Yeah, divided by C. This is the time, and plus 2 RTT, right? So this is one RTT, this is another RTT. And then we still have some file inside the HTML file. So n inline objects. Oh, so I made a mistake in here. It's S0. I made a mistake. I'm sorry. So you can see we are using 2 RTT to get the HTML file. And the next step is to establish the TCP connection again, because we need to get another file inline objects file. You can consider this one as images, like the pictures on the web page. And the first one is the TCP connection again. Yep. So, and for this part, we will have how many times, because we have so many inline files, then we need to have many times of that. You can see we have n of inline files, so we need to times n for this part. So that's how we do the calculation. Is that okay? So we just add them together. So one RTT, so it's 2 RTT. And we can write it down, 2 RTT plus S0 divided by C m plus n times 2 RTT plus we still need to send a file which is S divided by C in here. So I forgot to draw this part. Because we need to send it, right? We need to send the file in here. So which is T equal to S divided by C. And repeat for n times because we have to send them one by one. And what's the second RTT for? So are you talking about this part? This part? Okay, so we have to have 2 packets. I mean, the first packet obviously is in here. We need to take 1 round trip time to reach the server side and receive the feedback to establish the TCP connection. So once we have the TCP connection, then we can request for file. So firstly, we need to establish the TCP connection. Then we can request the file. So that's the reason why we have 2 RTT to get 1 file. So every file we get, we need to take 2 RTT in HTTP 1.0. So that's how we got the calculation and replace the RTT with D in here. So it's 2D plus S0 divided by C plus N times 2D plus S divided by C. So I think it's this one. Yes. So only after receiving the HTTP response, we can receive the file. Yes. So this one is not HTTP response, actually. It's the TCP connection. It's just like every time we need to say hi to each other. So every time you have to say hi to the server to get the stuff, get the page, get the file. Okay, so let's do the next one. This one, I will skip this one. You can do it by yourself. If you are not sure about the answer, you can check the recording. How about this one? You can do this one. Draw this one together. So what's the feature of that? It's persistent HTTP with pipelining. So it's the same idea but different method. So the first time we need to establish a TCP connection. So TCP. And the second time is we need to get the HTML file, and then we can request for the inline objects. Like we can request for many inline objects and then receive response. So this is the get HTML file. Get So that's how this is how it works. You can see in the HTTP 1.1 with pipelining, we save time because we can send a lot of requests and we only need to establish one TCP connection here. So this one is one RTT and one RTT and one RTT. So 3 RTT in total plus the time t equal to the size S0 divided by C, and this t equal to S divided by C and times M, because we have M files, right? So that's how we do the calculation. Then in total, we have 3 RTT plus S0 divided by C plus S N divided by C. So understand this one is very important. So I think it's this one. That's the calculation for the HTTP pipelining. If you can understand how they send the packet and how they establish the connection every time, then you can understand it. And next part is the DNS. Yeah, it's pretty easy. I think not much hard content. You can just go through all the questions by yourself in here. You can search. How about this one? When you open your browser and type this one, what is the minimum numbers of DNS requests? This one, do you have any idea? When you visit a website, so the minimum number of DNS requests sent by your local DNS server. So this question is tricky. Yeah, the answer is 0. So it's pretty tricky because we know when we need to get the IP address of it, we have to like somehow to contact a DNS server, right? But the question is not about the DNS server, but like how many numbers of the requested sent by a local DNS server. This is very tricky. And I think we will have a lot of this kind of question in the midterm exam. It's very easy to answer, but quite hard to get it right. So you can see this one. You can draw something in here, so you can easier to understand it. This one is your PC. So this one is your PC. Then every time you need to get the IP address, then you need to contact the DNS server. DNS. So this one is your local DNS. Local DNS. If your local DNS server already have the records, for example, in the table, it already have the table for google.com, web Google, then if it already have the table inside and the A record is 8.8.1.8, something like that, then you will directly return this records to you without sending any requests to the outside. So it doesn't need to contact the Google DNS to get the answer because it does have the cage. So that's the reason why we choose 0. And P2P, we always test T for tat question. So you can go through the content and try to understand it, how T for tat work. And can you try to answer this question? This one. So when you try to download a file, torrent file, but you don't want to share the stuff, is that okay? So you don't only want to download but not upload. So can you get a file? Just yes or no. So if you don't want to send the file, you cannot get the stuff. Then because if we are not sure, we can simply check by type it for tat. So this is how they work. For the tit for tat, we are like this. So every 30 seconds, we randomly select another peer and send the chunks. This is the important point. We will randomly select another peer and send the chunks. Even though we will mainly share our file with the 4 peer who is sharing with us on the top speed at highest rate. So if you share your file with a random customer, a random peer, and he will share it with you as well. So you help each other. But every 30 seconds, we will randomly select another peer. So that's the reason you can still get it. The answer is yes. Because you can be the random peer to receive the file, but obviously the speed will be very slow. So to answer this kind of question, you have to understand it. And the CDN, you can go through the content, just know what is CDN. I don't think we will test this part too much. So not much concept detail. We can test the like how to use it. And for the transport layer, it's about the TCP content. TCP content is just the version. So in the midterm exam, we will also ask what is the difference between different versions, but we will not ask this question directly. We will apply into a real question, real world scenario, and ask you what is the difference and what is the outcome of that. So that's it. And the pipeline protocols go back and selective repeat. We can have some question like this. Have some question like this. We can show you this kind of figure and ask you which one is the go back and which one is the selective repeat. So can you answer this question right now? So is this one selective repeat or go back and? Or it could be both. So is this selective repeat or go back again? Or both? You may need to check what is the difference between them, right? So go backend is pretty easy. Once we have a packet loss, then once we have a packet loss, then we will resend it, the file, the packet 2, and the packet 3, even we have received the packet 3. We will drop it because we need to get the packet 2 at first. So the packet 3 will be dropped, and hence in here, we will resend packet 2, 3, and 4, 5 because packet 2 is lost. That's the reason. So you can see for every request, for every packet we have received, it must be in the order, in the correct order. But for selective repeats, we will have separate timer. You can see the pictures in here. We can send them together, but we will keep in different timer, like in the same case, packet 2 lost. But in the selective repeat, we will just simply resend the packet 2, but we don't need to resend the packet 3 in here. So the packet 2 resend, and packet 3 and 4, 5 is already in the buffer. So put it in the buffer. So we don't need to send it again. So based on the difference on the selective repeat and the go back n, you can answer this question. Now this one could be selective repeat or go back n. But if something like this must be the go back n. That made a mistake. Like this. Like this. Yeah. So we may show you this kind of graph and ask you what is this? Could be is this go back n or selective repeat or both? And that's the question. Yep. And for the estimate RTT, how to do the calculation of this one. So this one is always be tested in the midterm exam. For this equation, for the alpha and beta, what's the value? And what is the, so why should we have this one at first? Estimate the RTT. So you need to answer the question, why do we need to have that one? To have the equation. So why do we need to do this kind of calculation? Because we need to adjust our timeout interval. If you still remember in the graph in here, we have a timeout in here on the calculation. So we need to dynamic change the timeout. We need to fix it every time we have the new RTT. So that's the reason why we need to do the calculation. And you can practice the calculation in the link. So do some calculation on this one because it's like 80 or 90% will be tested in the midterm exam. So do some calculation before your 10 exam to make sure you can understand it and save your time on the exam. And yeah, I think that's basically all the thing I want to mention in this part, the TCP and UDP. go through all this kind of graph by yourself. So try to understand every graph in the slides. And yeah, what is the fast retransmit? And answer this question by yourself. It's not pretty hard. And I think that's all. There's no flow control and other stuff. I think we will not test it. Yeah. So just a quick review for today. For the application layer, we will test HTTP, DNS, email, and P2P. And that's it. And we will not have HTTPS and etc. And there's no programming stuff in the midterm exam. And the principles for the transport layer will be UDP, TCP, and the version of RDD. This part is important. This part is must have. And what is the difference between them is also be tested. And the TCP, like fast retransmit, and the calculation of the timer, how to do the calculation, etc. And that's it. Any questions? And this is the preparation. So before you do the exam, you may need to do this kind of preparation. Yep. Can you see that? Preparation. So not much thing, just practice and practice. And you can have a screenshot if you want for the topics that may be tested. Yeah. Do we have a sample exam? I don't think we will have it, but we may ask you to go to the Inspira to do it. Like we will post 1 or 2 questions on the Inspira just to make sure you know how to use it, but maybe not mock exam. So if you want to do the preparation, it's pretty straightforward. Just go through all the labs and the maybe not labs, just the lecture slides. Go through all the recording and the lecture slides again if you have time, at least the slides. But if you have time, go through all the recordings and try to answer all the questions, all the quiz inside this part, inside the slides. And then that's it. And I do have some other material in the GitHub link. So you can check in the midterm information, we have some sample questions like the application layer sample question on this part. You can try to have a look and answer it. And do not forget the tutorial 1. We have the tutorial 1. You can do it by yourself and comparing with your answer. Then you will know which part you are not familiar with. And that's all good. Any question? Please let me know. And yeah, if you have no question, you feel free to leave. And have a good luck on your midterm exam. And we will have a help session next week. Yes, just have a quick look. Quick reminder, on week 5, we will have a assignment overview. So if you have time, you can come to here. And we will take like around 30 minutes to have a discussion about the assignment in week 5. And week 7, we will like have more details after the midterm exam. And week 8, we will discuss some key feature functions. Yeah, and that's it. Thank you for coming.
Hello, Ray.
Yes.
Can I borrow 1 minute to ask last week's lab question?
Yeah.
For the exercise.
Yeah, sure. Which part?
It is the last question. I'll share my screen of my results. Okay.
Yes, that's fine. Let me stop my sharing. And you can share it right now.
Yeah. Now can you see this web page?
Yes.
So I'm wondering what kind of output you want to see. So if I put this link here, it will show me this page.
Yes.
And if I continue to put something like this,
yeah,
I have 3 pictures. One is Python, and one is Java. And
yeah.
And one is R, and they all they give the similar output. And so apart from these, how about the 404 not found?
Yeah, can you try to visit a file does not exist? Like,
yeah, sure.
Just change to an invalid name.
I just give 1 line message saying 404 not found.
Yeah, and also check the status code behind this one. Like you can press F12 and check the status code.
How can I check it?
Like F12. View the source code or something. Just right click it. Yes, that's it. And go to the network section, and refresh this page. Refresh. Yes. And yes, you're right. You can see the status code is 404. So this one is correct. So make sure the status code is this one. So you are doing a good job. Yeah, I think you should have no problem with that.
Yeah, I'm I'm not sure because it asks us to send in the correct for error message. I'm not sure how did I send the for error message.
But you already done it.
Yeah, but because I just follow the code you provided with us, but I'm not pretty sure which part.
Maybe it's the return part. So you returned this message with the for error message, right? So when you make the response, the first row of it, you specify for error.
So as long as I have checked that this page is not found and I have an error handling message, that's fine.
Yeah.
Okay, so that's all for this question.
Yeah. I think your program is pretty good. Should not have any question.
Okay, got it. Yeah, that's all of my question. Thank you.
Okay, bye.